Article 680.10 of the National Electrical Code addresses underground wiring locations near swimming pools. Let's clarify several points related to this article based on the provided information. Firstly, concerning the definition of encasement, the National Electrical Code does not provide a specific definition for encasement within Article 680 or in the General Definitions section. However, Article 300.3 B offers a relevant definition. It states that encasement refers to the enclosure of conductors with firmly fixed materials that are electrically insulating and capable of withstanding external forces. Table 300.5 provides examples of such materials. Therefore, placing a raceway at the bottom of a trench and covering it with concrete could be regarded as encasement under this definition. The concrete provides electrical insulation and offers resistance against external forces. Secondly, regarding burial depth, if concrete covering is considered encasement, the minimum burial depth for a non-metallic raceway, as listed in Table 680.10, would be 18 inches. However, it is important to note that because the scenario isn't explicitly addressed in the code, consulting with a local electrical inspector or the authority having jurisdiction is advisable for specific guidance. Thirdly, the reason for the 18-inch burial depth requirement for non-metallic raceways without concrete encasement is related to potential damage. The depth may be due to concerns about potential damage from heavy equipment or other activities in the pool area. Concrete encasement provides additional protection against these types of hazards. Fourthly, your understanding of conduit placement is correct. If the wiring is not exclusively for pool equipment, Article 680.10 restricts conduit installation within 5 feet of the pool's inside wall. This restriction applies unless the wiring is essential for supplying pool equipment as permitted by the article. If sufficient space allows routing the wiring beyond 5 feet from the pool, it must be done regardless of whether rigid metal conduit, intermediate metal conduit, or a non-metallic raceway system is utilized. In summary, when installing underground wiring near pools, the National Electrical Code emphasizes safety through specific requirements. These requirements cover encasement, burial depths, and conduit placement. While the code provides guidelines, ambiguities can arise. In such instances, local electrical inspectors offer crucial insights and ensure compliance. Non-metallic raceways generally require an 18-inch burial depth to protect them from potential damage unless concrete encasement is utilized, which may alter the burial depth requirement, but this needs to be confirmed with the local inspector. Also, the definition of encasement, while not explicitly defined in Article 680, can be inferred from Article 300.3. Suggesting that concrete surrounding a raceway could be considered encasement. Remember that wiring not directly related to pool equipment must be routed at least 5 feet away from the pool's inside wall, where possible, to minimize risks and adhere to code. Always prioritize safety and code compliance by seeking expert advice and conducting thorough inspections during electrical installations near swimming pools. It is also important to consider other factors such as soil type, local climate conditions, and potential mechanical stresses on the raceway when determining the appropriate burial depth. Furthermore, consider the type of non-metallic raceway being used, as some are specifically designed for direct burial and may have different burial depth requirements than those listed in Table 680.10. When installing rigid metal conduit or intermediate metal conduit, ensure that this is corrosion resistant and suitable for the location as required by Article 680.10. Consider using coated or stainless steel conduit in areas with high moisture or chemical exposure to prevent corrosion and maintain the integrity of the electrical system. When routing wiring more than 5 feet from the pool, consider the potential for future landscaping or construction activities that could impact the wiring. It may be necessary to install the wiring at a greater depth or provide additional protection to prevent damage from these activities. Always use approved fittings and connectors for the type of raceway being installed to ensure a proper and reliable connection. Incorrect fittings can lead to moisture ingress corrosion and electrical failures. Consider the potential for ground movement or settling in the area where the wiring is being installed. Flexible conduit or expansion fittings may be necessary to accommodate movement and prevent damage to the raceway. When backfilling the trench, use clean, well-compacted soil or sand to provide support and protect the raceway from damage. Avoid using rocks or debris that could puncture or crush the raceway. Label the raceway with appropriate markings to indicate the type of wiring and voltage being carried. This can help prevent accidental damage during future excavation or maintenance activities. Document the location of the underground wiring on site plans or as-built drawings. This can help prevent accidental damage during future excavation or maintenance activities. Coordinate with other utilities such as gas, water, and sewer to ensure that the underground wiring does not interfere with their facilities. Maintain proper clearances between the wiring and other utilities to prevent potential hazards. When working with electrical systems near swimming pools, always follow safe work practices and use appropriate personal protective equipment such as insulated gloves and safety glasses. Ensure that all electrical equipment is properly grounded to prevent electrical shock hazards. Regularly inspect the electrical system for signs of damage or deterioration. Repair or replace any damaged components promptly to prevent potential hazards. Consider using ground fault circuit interrupters, or GFCIs, to protect circuits that supply pool equipment. GFCIs can detect small ground faults and quickly shut off power to prevent electrical shock hazards. Install warning signs or barriers to prevent unauthorized access to the pool area and electrical equipment. Educate pool users about the potential hazards of electricity and water. Follow all applicable federal, state, and local regulations when installing and maintaining electrical systems near swimming pools. These regulations are designed to ensure the safety of pool users and prevent electrical hazards. It is also important to consider the specific requirements of the pool equipment being installed, as some equipment may have additional wiring or grounding requirements. Consult the manufacturer's instructions for specific guidance. In addition to the requirements of Article 680.10, other articles of the National Electrical Code may also apply to underground wiring near swimming pools. These articles may cover topics such as grounding, bonding, overcurrent protection, and wiring methods. Always consult the latest edition of the National Electrical Code and any applicable local amendments to ensure that all electrical installations comply with applicable requirements. When in doubt, consult with a qualified electrical contractor or engineer for assistance with designing and installing electrical systems near swimming pools. These professionals have the knowledge and experience necessary to ensure that the installation is safe, reliable, and code compliant. Remember that electrical installations near swimming pools can be complex and potentially hazardous. It is important to take the time to understand the applicable requirements and follow safe work practices to prevent accidents and ensure the safety of pool users. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals for assistance with specific electrical installations. In addition to the electrical code requirements, consider the aesthetic aspects of the wiring installation. Conceal or minimize the visibility of the wiring as much as possible to enhance the appearance of the pool area. Use appropriate landscaping or screening to hide conduits and junction boxes. Consider the long-term maintenance requirements of the wiring installation. Provide access points for inspection, testing, and repair. Use durable materials that can withstand the harsh environment near a swimming pool. Consider the potential for future expansion or modifications to the pool area. Provide adequate capacity in the wiring system to accommodate future needs. Design the wiring system to be flexible and adaptable to changing requirements. Coordinate the wiring installation with other trades such as plumbing, landscaping, and concrete work. Ensure that all work is properly scheduled and coordinated to avoid conflicts and delays. Inspect the wiring installation thoroughly before backfilling the trench. Verify that all connections are tight, supports are secure, and clearances are maintained. Conduct a continuity test to ensure that all circuits are properly wired. Perform a ground resistance test to verify the effectiveness of the grounding system. Document the results of all inspections and tests. Maintain records of all wiring installations, inspections, and tests. Provide copies of the records to the pool owner or operator. Train pool personnel on the proper operation and maintenance of the electrical system. Provide instructions on how to identify and respond to electrical hazards. Post emergency contact information near the pool area. Include the phone numbers of the local fire department, police department, and electrical utility. Develop an emergency response plan for electrical incidents. Outline the steps to be taken in the event of an electrical shock, fire, or other emergency. Review and update the emergency response plan regularly. Conduct drills to ensure that pool personnel are familiar with the plan. Provide first aid training to pool personnel. Ensure that they are familiar with the treatment of electrical shock and other injuries. Keep a well-stocked first aid kit on hand. Include supplies for treating burns, cuts, and other injuries. Review and update the first aid kit regularly. Conduct regular safety audits of the pool area. Identify and correct any potential hazards. Document the results of the safety audits. Implement a system for tracking and resolving safety issues. Encourage pool users to report any safety concerns. Provide a mechanism for reporting safety concerns anonymously. Investigate all reported safety concerns promptly. Take corrective action to address any identified hazards. Communicate the results of safety investigations to pool users. Promote a culture of safety in the pool area. Encourage pool users to be aware of their surroundings and report any potential hazards. Provide ongoing safety training to pool personnel. Recognize and reward employees who demonstrate a commitment to safety. In addition to the requirements of the National Electrical Code, other codes and standards may also apply to underground wiring near swimming pools. These codes and standards may cover topics such as accessibility, energy efficiency, and environmental protection. Always consult the latest edition of all applicable codes and standards to ensure that all electrical installations comply with applicable requirements. When selecting electrical equipment for use near swimming pools, consider the environmental conditions in which the equipment will be installed. Choose equipment that is rated for outdoor use and can withstand exposure to moisture, chemicals, and ultraviolet radiation. Use corrosion-resistant materials to prevent deterioration of the equipment. Install the equipment in a location that is protected from direct sunlight and rain. Provide adequate ventilation to prevent overheating of the equipment. Consider the potential for vandalism or theft of the equipment. Install security measures to protect the equipment from unauthorized access. Use tamper-resistant hardware to prevent tampering with the equipment. Inspect the equipment regularly for signs of damage or deterioration. Repair or replace any damaged components promptly to prevent potential hazards. Keep the equipment clean and free of debris. Remove any vegetation that could obstruct access to the equipment. Follow the manufacturer's instructions for operating and maintaining the equipment. Use only qualified personnel to perform maintenance on the equipment. Disconnect power to the equipment before performing any maintenance. Use appropriate personal protective equipment when performing maintenance. Dispose of any waste materials properly. Recycle any recyclable materials. Prevent pollution of the surrounding environment. Protect the health and safety of the public. Comply with all applicable laws and regulations. Always consider the safety of the public when planning and implementing any electrical installations near swimming pools. Take steps to minimize the risk of accidents and injuries. Provide adequate warnings of potential hazards. Ensure that all electrical equipment is properly grounded. Install ground fault circuit interrupters to protect circuits that supply pool equipment. Regularly inspect the electrical system for signs of damage or deterioration. Repair or replace any damaged components promptly to prevent potential hazards. Encourage pool users to report any safety concerns. Take all necessary precautions to prevent electrical accidents near swimming pools.